Hello everyone, welcome back to my YouTube channel. In this video, we will start a new topic of class 9th, that is laws of motion. Laws of motion were proposed by Sir Isaac Newton. These laws of motion are the foundation of physics and it describes how objects move. These laws can be applied to everything in day-to-day life, like an apple falling from a tree to rocket launched in the space. So understanding these laws of motion is very essential. So let us start with our class. Let us discuss about motion first. Motion is all around us and it is an essential part of our lives. From the planets orbiting the sun to cells in our bodies, everything is in motion. So understanding the science behind motion can help us to create better technology, improve our health and explore the universe. Let us see some examples of motion. First example, here you can see the planets orbiting the sun, a bird flying in the sky, man running, a man cycling, children swinging. So as you can see here, everyone is performing different types of motion or different kinds of motion. Here you can see one is performing linear motion, someone is performing oscillatory motion, someone is performing circular motion, and the bird which is performing a random motion. So motion can be of different types, can be of different kinds. Let us see some basic types of motion. So the three types of motion are linear, circular and periodic. Linear motion is a motion when the body moves in a straight line, while circular motion is a motion in a circular path. And periodic motion is that motion which repeats itself over a time, like the motion of pendulum. So these are the three basic types of motion which you have learned already in the lower classes. Now let us understand important concept, that is relative motion. To understand this concept, let us see one example. Imagine that a passenger is traveling in a train and is sitting in the window seat. Now when he sees from the window outside, he sees that the trees and the houses are moving. The trees and the houses appears to be in motion for that particular passenger. But in reality, the train is moving and the trees and houses are at a fixed point, or they are at a rest, they are stationary. Let us consider this passenger as observer 1 and let us imagine one observer which is standing outside on the road. We'll name it as observer 2. So for observer 1, the trees and the houses are in motion and the train is stationary since he is sitting inside the train. But for the observer 2 who is standing outside, for him the train is in motion and the trees and houses are at rest. This is what the motion is, a relative concept. So motion of an object depends upon the observer. For one observer, the same object can be in motion, and for other observer, the same object can be in rest. This is what is motion, is a relative concept. Let us see one more example. Here, the passenger is standing on a platform, and for him, the tree is at rest. Now, when the passenger is in the train, he says that the tree is in motion. So the object is same, that is a tree. However, tree is the object. For this observer, the tree is at rest because he is standing on the ground. And for this observer, as he is inside the train is moving. For him, the tree appears to be in motion. This is the concept known as motion, relative motion. I hope you understood what is relative motion. Let us discuss about uniform and non-uniform motion. Now, uniform motion is such a motion of a body in which the body covers or the object covers equal distance in equal interval of time. Example, movement of fan blades, motion of earth around the sun, motion of pendulum. And non-uniform motion is such motion of an object where unequal distance is covered in equal interval of times. For example, motion of vehicle being driven through heavy traffic. Now vehicle, sometimes it will travel with 25 kilometer per hour. So in 1 hour it will travel 25 kilometer. Other 1 hour it will travel 15 kilometer. So distances are not equal, but the time intervals are equal. This motion is known as non-uniform motion. Let us have a small discussion on scalars and vectors. Scalar quantity and vector quantity we have already studied in class 8. The major difference between scalar quantity and vector quantity is that in scalar quantity we only include the magnitude, while in vector quantity we include direction as well. For example, when I say the speed of the car is 35 km per hour, so here I have only included the magnitude, that is 35. I'm only including the unit and magnitude 35 km per hour to describe the speed of the car. But when I say that the car is moving with a velocity 35 km per hour towards north, so here I'm specifying the direction towards north the car is moving. So this becomes a vector quantity. The velocity of wind is this kilometer per hour, and from the wind is blowing from south to north. So here also we mention the direction as well as magnitude. Some examples of scalar quantities are speed, volume, mass and time. Vector quantity examples are force, velocity, acceleration, momentum. Let us have a discussion now on next subtopic, that is distance and displacement. Distance is the length of actual path traveled by an object in motion while going from one point to another, whereas displacement is a minimum distance between starting and finishing points. Let us understand this with an example. Now here we have a boy who is riding a cycle, and the starting point is this. Let us name the starting point as A, and he's riding a cycle and he's going through this road, and finally he end his journey here. Let us name the ending point as point B. Now from traveling from point A to B, he has traveled through different roads, different ways he has traveled. So this red line which you can see, this is his traveling journey, and this is what the distance he has traveled. So we'll measure from point A how much distance he has traveled. This will be a distance, but displacement is nothing but minimum distance. Now this is a one way to travel from point A to B. There can be numerous ways to travel from point A to B. I can also travel like this. I can also travel from this to this. But displacement is nothing but minimum distance between the starting and finishing point. If you see, this is point A, which is the starting point, and point B. From point A he has finally reached point B, no matter what he has done in the middle. In displacement only matters the starting point and the ending point. So if we draw a straight line here, so finally he has reached from A to B. This is what the minimum distance traveled by him, and this is what the displacement is. Distance is different, displacement is different. Distance is the actual path he has traveled, and displacement is a minimum distance between the 2 points, starting and ending point. In between what he has done, it doesn't matter in displacement. Let us solve a problem. So here you can see a boy who's riding a cycle again, and he wants to travel from A to point C. He has to travel from point A to point C. Now he has two ways. He can directly go from point A to C, or he can travel from A to B, B to C. Now the red mark shows that the actual distance traveled by him. So here first he went from this tree to the house, and again from the house to point C, another tree. Now from A to B and B to C. His aim was to travel from A to C. His aim was not to go to B. But the actual distance traveled by him was from A to B is 4 meter, B to C is 3 meter. So total we have 7 meters. This is the distance traveled by him. So 7 meter is nothing but distance. Okay. Now what is displacement? Displacement is the shortest distance between starting and ending position. Now A is our starting position and C is ending position. What is the shortest distance? This one. That is a straight line we have to draw from starting and ending position. So 5 meter is our shortest or minimum distance between the starting and ending point. So this becomes our displacement. So this is our displacement, and 7 meter becomes our distance. Now there is one problem given in your textbook. use your brain power. So there are two figures. Let us read the first question. Every morning, Swarali walks around the edge of circular field having radius 100 meter. As shown in the figure 1.2a, means it is talking about figure A. If she starts from point A, so this is a point A, takes one round, how much distance has she walked and what is her displacement? So we need to find distance and displacement. Now see here, she has started from this position and completed one round, and again she came back to the original position, that is point A. Now what is this complete one round? We have to find the distance, what distance she has traveled. Now this is a circular track, this is a circle, we can apply the formulas of circle as we have given the radius. So radius is 100 meter, we can apply the formula to find the circumference, because this is the circumference of circle. The formula is 2 pi r. So 2 pi r. So we'll multiply 2 into pi into r. So it will be 2 into 3.14 into r is given 100 meters. So it is 100. Now since this is 100, so we'll shift the two decimal points here. It will be 314 multiplied by 2, which will be 4 2s are 8, 2 1s are 2, and 2 3s are 6. So our total distance will be 628 meters. This will be our total distance. The next question asked is, what is a displacement? The displacement is the minimum distance between starting and ending point. Only starting and ending point. In between where she has walked, where she has gone, doesn't matter. Now what is our starting point? Point A. What is our ending point? Point A. So our starting point and ending point are the same. So what is the displacement here? Is it 628 meter? No, it is the distance traveled. Here the displacement is 0 meter, because her initial point is also same and final point is also same. Starting and final point are same. That's why the displacement will be 0, because from the same point he started his journey, at the same point he ended her journey. I hope you got the difference between distance and displacement. Let us see the second example. If a car starting from point P goes to point Q. So this is a car starting from point P and goes to point Q and then returns to point P. So first she travels from P to Q and again from Q to P returns. What is the displacement and distance? So as you can see, from P and Q the total distance is 360. So from P the car started and went to Q. So distance travel is 360 meters. From again Q, from point Q the car went to point P. So the total distance will be 360 from P to Q and 360 from Q to P. So it will be 360 plus 360. That will be 720. This will be our distance travel. Now what will the displacement? Again it will be 0, right? Displacement will be 0 meter and distance is going to be 720 meter. Why displacement is 0? Because the car is starting from point P, going to Q, again from Q coming to P. What is the starting point? P. Ending point also P. So initial and final point are same. Again the displacement is 0. Okay, I hope you understood the difference between displacement and distance using these three examples. Let us differentiate between distance and displacement. This is how we are going to present in an examination. The first point will be the definition of distance and displacement. The complete length of path between any two points is called distance, and displacement direct length between any two points will measure along minimum path. You can mention any two points as the initial and the final points. Then distance is a scalar quantity as it has only magnitude and no direction, where displacement it has also direction, so it is a vector quantity. Distance is always positive while displacement can be positive, negative and even zero. Let us elaborate this third point with an example. Consider a coordinate system like this. Suppose this is your origin, this is 1 unit distance, this is at 2 unit distance. This is -1, -2. For example, you are standing on the origin, let us say point A, and you're going from point A to point B, and again from point B to point C. Now what is the distance first traveled by you? So distance will be from A to B, it is 2 units, again from B to A it is 2 units, and again from A to C it is 2 units. We will not subtract that 2 because we have to find the distance. Distance is the measurement which you have traveled throughout. So it will be 2 plus 2, 4 plus 2, so it will be 6 units. So distance will be 6 units. Now what about a displacement? Displacement, in displacement we take about 2 points. First is the starting point. So this is our starting point, this is our ending point. So point A is initial point, point C is the final point. Now we will not consider point B because it is not a starting point also, not an ending point also. So we will see this distance, that is from A to C, and we will also see the direction, magnitude as well as direction. So -2 will be our answer. So displacement can be negative. Now in this -2, 2 indicates the magnitude and minus indicates the direction. It is a negative side of the coordinate system. So thus distance is always positive, but displacement can be positive, negative and even zero. A discussion on the subtopic, that is speed and velocity. The distance covered by an object per unit time is called speed. The rate at which object changes position in certain direction is called velocity. So whenever the direction comes, it will be velocity, because speed is scalar quantity, velocity is vector quantity. When we talk about speed, it is related to distance traveled by the object. When we talk about velocity, is related to displacement of the object. So the formula goes here: speed is total distance upon time required, velocity is displacement upon time required. So units, what are the units? In SI system it is meter per second, CGS system it is centimeter per second. For distance we use meter, to measure distance we use meter, for to measure time we use seconds. So the unit of speed becomes meter upon second, that is meter per second. And in CGS, that is centimeter gram system, it is centimeter per second. Now the unit of distance and displacement are same only. Similarly, the unit of speed and velocity also same. The difference is only in, it is speed is a scalar quantity and velocity is vector quantity. There is no difference in units. Let us discuss the points for differentiating between speed and velocity. First point is the definition. The rate at which object covers a distance is known as speed. Now rate only means that per unit time. Velocity can be defined as rate at which an object changes position in a certain direction. Speed is a scalar quantity, velocity is a vector quantity. Speed is always positive, or it is never negative or zero. Velocity can be zero, negative or positive. Average speed will continue to count even if object changes the direction. But in the case of velocity, the object changes with the change in direction, the velocity also gets changed. Therefore, the object must follow one direction. Let us elaborate this last point. For example, I am traveling from point A to B with a car, and my direction is like this, my path is like this. So when I calculate the speed, I will calculate the distance of this path from A to B and divide it with the time taken for me to travel from A to B. This will be my simple speed. But in velocity, from traveling from A to B, I have changed the direction. Like while traveling on this road, I have traveled in this direction. Again, I have traveled in this direction. Again, I have changed my direction. I have traveled here. Again, I have changed my direction. So after particular of a certain interval of time, I have always changed my direction. Sometimes left, sometimes right, sometimes straight. So the velocity changes there. It is not same at all the positions. So we need to calculate different velocity at different time intervals. because velocity depends on direction and speed doesn't depend upon direction. So this is what the fourth point tells us. I hope you understood the difference between speed and velocity. Let us move to the next part, that is solving numericals. So we'll solve numericals which are related to topics which you have learned today, that is distance, displacement, speed and velocity. Already we have solved the numericals based on distance and displacement. Here we have some numericals based on average speed and velocity. Let us read the question. An athlete is running on a circular track. So just highlight this circular track. He runs a distance of 400 meter. So they have already given us the distance. So our distance will mark is as small d. It is 400 meter in 25 seconds. So they have also given us times. Time is 25 seconds. Before returning to his original position, what is his average speed and velocity? We need to calculate the speed and velocity of that athlete. So simple formula we will use, that is what is speed? Total distance upon total time. So the total distance traveled by him is 400 meter. So our speed will be, so we'll add the formula distance upon time. So what is our distance? 400 meter upon time is 25 seconds. So just calculate it, divide it. So we'll get 25 ones are 25, then 25 six are. So it is 16 meter per second. So speed comes to be 16 meter per second. Second question they have asked, what is the velocity? Now what is a velocity? So velocity is nothing but displacement upon time. They have given us displacement? No. What they have given us? They have given us circular track. And we know that in a circular track, our initial position and final position is same, right? So here, though the distance is 400 meter, the circumference of the circular track is 400 meter. Total distance is 400 meter. But displacement will be 0. So velocity will be 0 upon 25, which is nothing but 0 meter per second. I hope you understood this sum, why the speed is 16 meter per second and why the velocity is 0 meter per second. Since they have mentioned it a circular track, in a circular track the displacement will be 0 since the initial and final position will be same. While the distance they have given already 400 meter the athlete has traveled. This is how you solve the sum. And when you solve in your exams, you need to mention the given data like distance is 400, time is 25 seconds. Then you need to write the formula also. Speed is distance upon time. Then you will solve the question step by step. Let us solve one more question. So a person swims 100 meter in first 40 seconds, 80 meter in next 40 seconds, 45 meter in last 20 seconds. So here basically they have given us three time intervals. First 40 seconds, next 40 seconds and last 20 seconds. In these three time intervals, he is traveling different distance, like first he is traveling 100 meter, then 80 meter, then 45 meter, and we need to calculate the average speed. Now what is this formula for average speed? Average speed is nothing but total distance upon total time. So here we have not given the total distance, we need to calculate the total distance first. So we'll calculate the total distance first. How we'll calculate total distance? We'll simply add this 100 meter, 80 meter and 45 meter. 100 plus 80, 180. 180 plus 45 will yield you 225 meter. So this is the total distance traveled. And denominator we write time required. So they are given three interval of time. So again we need to find the total time. Total time. So we'll again add 40 seconds plus 40 seconds plus 20 seconds. So is 100 seconds. Now we are ready with the data, total distance and total time, and now we can solve speed or average speed is equal to total distance, that is 225, and divided by total time, that is 100. So we'll get here 2 digits we will shift towards left, so 2.25. Distance is given in meter, time is given in seconds, so our answer becomes 2.25 meter per second is the average speed. The person swims with an average speed of 2.25 meter. This is how you have to solve the sum step by step. First you have to read the data, then you have to write the given part, what is the distance. So then you have to find the total distance. There are three interval of time given, total time you have to find. Write the formula, average speed is total distance upon total time. Then we will solve these steps. So and a final statement. Afterwards, the person swims with an average speed of 2.25 meter per second. Now this sum is similar to the sum which we did previously. So you can try solving this sum and comment down your answer in the comment box. And this is the end of today's session. In the next videos, we will study about different subtopics of this chapter. Thank you.